All right, here we go. Test review, Unit 8. I know it says Unit 7, but it's actually Unit 8, polygons and quadrilaterals. We will do as much as we can here. I will try to get all of this into one video if I look like, because there's a lot of material here. If I look like I need to cover two, I'll cover two. Okay, here we go. Ready to begin. Question number 1, 2, 3, 4, whatever. Alright, so let's look at these, and some of these things you might need to also make sure you add into your formula sheet. So what's the formula for the sum? The formula for the sum again was 180 n minus 2. That gives you the sum of the interior angles. Okay, if I want to find each interior angle, it would have been that 180 n minus 2 divided by n, and n stands for the number of sides, so keep that in mind. So if I have a 35 I can say 180 35 minus 2 and get. Alright, so now here's something else I would add. I might add this chart on here so you have all of this here on your formula sheet, somewhere maybe on the back, whatever, somewhere. Anyways, the reason why I would add that is because if I'm here and it says there's a heptagon, I know that adds up to 900 degrees. If I add up all of these angles here, I get 760. And then if I subtract those two, I get 140. So that means the seventh angle is 140 degrees. Okay? Let's see here. Sum of the interior angles of a polygon has 3,780. I am not going to ask you to do that. I wouldn't ask you to do that one, but I would ask you to do number 6. What's the measure of each interior 18-gon angle, so on and so forth. So here I would say 180, 18 minus 2 divided by 18. And when you do that, 180 times 18 minus 2 divided by 18, you get 160 degrees. All right. So, how about something like this? Okay, again, how many sides does this have? 1, 2, 3, 4, 5, 6, 7, 8. 8 sides. I add up all of these angles, all the x's together. If I add up all the x's together, I should get 43x. If I add up all the numbers together, I should get 239. This has 8 sides. So according to that, 8 sides should be able to add up to 1080, and then I would solve. Okay, actually, oops, I forgot to add in the 153, so this is actually, say, 392 equals 1080. So then I would say 1080 minus the 392, and then divided by, helps if I type it correctly, and then divide that by 43, and you get x equals 16. So all I did was subtract, and then divide, and I got x equals 16. Alright, if x is a regular polygon, okay, regular polygon means they're all the same. So if this is 5 sides, and the sum of a 5-sided figure is 540, then I can say 540 divided by 5, which would give me 108, and then that would equal the 7x minus 31, so 7x plus 31. Apparently I forgot how to read. So then you would subtract and then divide, and when you do that, you should get x equals 11. So there you go for that. Okay, sum of exterior angles. If it's an exterior angles, the sum is always 360. I don't care how many sides, it's always 360. So if you want to find the measures of each exterior angle, and you can add that in there, 360 divided by the number of sides will give you that. In this case, it's a nonagon, so I'm going to divide 360 by 9, which would give me 40 degrees. Okay, and then from there, let's look at the next one. If they give you an exterior angle, then if you say 360 divided by the angle, the exterior angle, then you would get the number of sides. So if I say 360 divided by 24, I get 15. So here there's 15 sides. Okay, now notice this one is 162. So you have to keep in mind that the interior is 162, so you can easily find the exterior by subtracting. So 180 minus 162 gives me 18. So that I would divide by 360, so 360 divided by 18, which is 20. I was running out of space there, but you get the idea. All right, so again, how do I solve this? Add up all the x's, so 11 plus 4 plus 6 plus 9, and that would give me 40x. And then add up the numbers. Let's see here. 67 minus 5 plus 29 plus 61 plus 13 minus 15. You get 150 positive. Set that equal to 360, and then you would solve. I'm sorry, that 11 plus 4 plus 6 plus 9 is 30, not 40. I have no idea what I was doing there. So anyways, subtract and then divide, and you should get that x is equal to 7. A lot of these, again, guys, I'm going to try to get you to say x equals, okay? Pre-AP, maybe ask for a little bit more, but right now, that's good. Don't forget to have this, like these properties for parallelograms, trapezoids, isosceles, rhombi, all that stuff for your formula sheet. Maybe use this as your formula sheet and just add the other stuff that I've told you so far on the back. And then that should help you answer properties about parallelograms, rhombi, all that other stuff. So, let's look. Okay, so maybe I did give you something like this, and look, it says EB is 16. And I know CD is 16. ED is 25. So then that's 25. Remember, parallelograms, opposite sides are parallel and congruent. EC is 34. So, I'm sorry, BF is 11, so that's 11. And this is 11. If EC, the whole thing, is 34, I can divide by 2 and say that's 17 and 17. That should answer most of these questions. Let's see, BC, 25. BD, 11 and 11 is 22. Okay, because that's this whole thing. FC is 17. CD is 16. Okay, so now how do I do angles? Okay, so let's see how we could go from here with this is the information they give you as far as degrees is concerned. Now look, the first question asks for what is EDC, so that would be this angle here. Okay, keep in mind that this angle and all of this, the big angles, ignore the diagonals part, those add up to 180. So if I say 180 minus 55, I would get 125. So this right here would be 125 degrees. Okay, now EBD, if this is 67, so is this. Remember, opposite alternate interior angles are the same. Learned that last semester. BEC. Okay, so now here, think about this. And I'll enlarge this a bit, and I'm going to erase some stuff here that I don't need. Okay. This whole thing is 55. This right here is 20. I totally forgot what. 24. Okay. Keep in mind, this angle is 55, so is this. So if I subtract 55 minus 24, helps if I'm on the right thing. 55 minus 24, I get 31. Now, keep in mind, that flips. That's 31, that's 24, and they want BEC, so they want this one, so that's 31 degrees. Okay, and then finally DBC, if this is 67, and you know the whole thing is 125, you can subtract and get 58 degrees. Okay, if y'all have questions about those, feel free to ask, but there you go. All right. More of what you're going to get is something like this, where you need to recognize that these two are equal because they're opposite. So on a parallelogram, the opposites like that are equal. So here I would say minus 8x plus 39, you get 4x is equal to 56. Divide by 4, and x equals 14. Now again, for my CP, that's probably where I would stop. But if I want to find angle N here, my pre-APs, maybe I do make y'all say, what is 12 times, say, 14 minus 39, you get 129. Like this is 129 degrees. Subtract that from 180, and you get 51 degrees for a final answer to get that one. Okay, that would be the measurement of angle N. Now on this one, you need to remember that if they're like side by side like this, they're going to add up. So this is 19x minus 10 is equal to 180. So add and then divide, and you got x equals 10. Oh, damn it. Okay, so if x equals 10 and I want to find angle R, remember R and T are the same, so I can put the 10 here and say 10 times 14 minus 4, that would be 136 degrees. So for number 17, you're saying here this is 7x minus 13. Keep in mind that that means this is also 7x minus 13. Add those together, you get 14x minus 26. And that would equal the whole diagonal, which is 16x minus 38. Okay, variables to the left, numbers to the right. Minus 14, you get 2x. Plus 38, you get 12. So x is equal to 6. And again, for my CPs, that would probably be done. Find BD, put the 6 here, say 16 times 6 minus 38. 16 times 6 minus 38 is going to be 58. So, pre-APs, maybe I ask for a little bit more there, but we shall see. Okay, so there's a problem number 18 asks you to determine whether something's a parallelogram. But, okay, so what I'm going to actually say is the problem you're going to get is going to be, tell me if it's parallelogram, rectangle, rhombus, or square. You need this chart and the distance formula and slope formula to be able to do that. Problem 18 and 28 would both do this, and I will show you how you would set that up. Okay, so how this works is this. You're going to combine the first and third point, because that would make a diagonal. Because like if you say, think of it like this, W, X, Y, Z, you want to look at the diagonals, okay? So, think along those lines. You're going to combine the first and third point, and the second and fourth point, okay? So that's what I've done here. Okay, now, what are my x coordinates for the w and y? 0, -1. What are my y coordinates? 8, -1. Okay, for x, z, it's 6 and -7. And then it is 10 and -3. Slope, y's are on top, x's are on the bottom, y's are on top, x's are on the bottom, and then you plug it in from there. Alright, so in this case, what happens here is you get that this is 9.1 and this is going to be 18.4. So this is an x. The distances are not the same. And as far as the parallelograms, or I'm sorry, as far as the slopes go, you get 9 and 1. So this is an x also. And because they're both x's, that tells you that this is a parallelogram. Okay. So how about let's look at 28 so you can see how that compares. So same setup. Notice AC, first and third, second and fourth. Okay, x's, 3 and 8. Y's, -4 and -9. X's, 10 and 1. And then -2, -11. And then again, notice how these get recopied over here with the y's on top, the x's on the bottom, y's on top, x's on the bottom. Okay, if you type those in, what do you get for answers? Let's find out. Okay, so keep in mind here, this one, the distances are not the same. These technically are opposite reciprocals, so this is going to be the same. So yes, this is check and an x and a check. So that would be a rhombus. So this right here is a rhombus. Now, again, just as some for examples of perpendicular, you might want to make sure you realize like perpendicular, like if I want to know something's perpendicular, like it could be 3/2 and then -2/3, or vice versa. It could be 4 and -1/4. It could be 0 and undefined. It could be -1 and 1. All of these would be examples of perpendicular. So if you see something like that, that would be it. If they are completely different, then they're not. Remember, notice that one is positive, one is negative. Okay? And we'll kind of go from there. Okay, guys, I'm going to pause this one right here. So let's consider this part 1. I realize this is kind of long, especially for just a regular test, but there are some things that require my attention, and so I'd rather go ahead and pause it, and I will make a second part later. So thank you so much for your time. Again, try to make sure you watch both videos, and that way if you have time, I'd be able to answer any questions maybe the next day. All right, thank you. Y'all take care.